What's up? Let's talk about phylogenies. So a phylogeny is a hypothesis. That's the first thing to remember is that a phylogeny is a hypothesis based off of the data that was used to create it. Now, a phylogeny is a hypothesis about the evolutionary relationships and the descent of organisms used in the data set. So if we look at a phylogeny here, this is one phylogeny, this is another, this is the other. They're all the same thing, but I highlight some different things in them, right? But a phylogeny, right, shows the descent of organisms. So this shows that basically A and B were the descendant of a common ancestor. C and D were the descendant of a different common ancestor. So it shows a pattern of descent, right? So what we would say is that if two different taxa are closely related, such that they share the most common ancestor, we call these sister taxa, right? So A is sister to B, C is sister to D, right? But C is not sister taxa to B. Why? Because C's closest relevant or closest relative, closest organism in terms of evolutionary descent is D, right? So C is sister to D. Now, one of the things that we have to remember is that if we look, this is known as a branch. This is a terminal branch, right? So the long extensions of the branches where they come down and they meet or they connect, this is a node. So you have a branch here, node here, branch here, node here, right? And so at a node, right, they can flip or rotate. So what can happen is this can rotate at this node and we can put C over or D over here and C over here, right? So they can rotate. So make sure you think about that when looking at different phylogenies, okay? Now, when we talk about evolutionary descent, it's important to understand the descent and what the ancestor is, because as things come from a common ancestor, they should share some similarities associated with them, right? So when we look at the evolution of organisms and the groupings of descendants, we often talk about three different organizational patterns: monophyletic, paraphyletic, and polyphyletic. In a monophyletic setting, right, or something that is monophyletic, it is the descendants, all of the descendants, plus the ancestors. So here we have grouping A, B. This plus the common ancestor is monophyletic. If we look C, D plus this common ancestor down here would be monophyletic, right? But if I wanted the whole thing, and if I wanted to look at the monophyletic group of the whole thing, I would have to A, B, C, D, plus of this common ancestor way down here, okay? If something is paraphyletic, it is descendants, right? But, and the common ancestor, but not all of the descendants. So some of the descendants are left out, right? So here we have the descendants A, B, and C plus their common ancestor, but descendant D is not included in this group. So this is paraphyletic. So it's the descendants, the common ancestor, but not all of the descendants. Now, if something is polyphyletic, it is the descendants, but not the common ancestor, right? So here we have A, B, and C, and this descendant, or this common ancestor, but notice we do not include this common ancestor here, which makes it polyphyletic, right? So the difference between polyphyletic and paraphyletic is whether or not that common ancestor is included. So here we include it, so it's paraphyletic, ancestor included. Here it's not, so it's polyphyletic, right? So think about those terms when we talk about evolutionary relationships or we talk about phylogenies. The other thing to keep in mind is that sometimes you will see the term clade used instead of monophyly or a monophyletic group. So a monophyletic group is often referred to as a clade.